How's it going, everybody? In this video, we're going to take a look at VLANs, or the Virtual Local Area Network, or a VLAN. Now, if you don't know what a VLAN is, that's okay. I'm going to tell you. So, for those of you that are familiar with what a VLAN is, basically it's a way to take a Cisco switch, or it doesn't have to be Cisco, it can be any vendor's platform, and you're going to basically take the operating system and configure it to logically break up that switch. You're going to break that switch up into multiple broadcast domains. So instead of me trying to explain that to you, I'm going to just draw it out because it's easier to do it that way. So I'm going to go ahead and grab my pen pad here, and we're going to get rocking and rolling here on how to break this down. It's actually a very easy concept. I'm assuming everybody here knows what that does, but just for those of you that are coming from maybe you haven't touched CCNA in a while, and you're just getting into CCNP switch, maybe this is your first course in CCNP, good for a refresher. So we have a situation like this where we have the switch sitting here, and this could be any numbered ports. It could be a 12 port, it could be a 24 port, it could be a 48 port. Really doesn't make any difference. The portion here that we want to focus on, though, is the actual VLAN itself. So I'm just going to draw a few ports here on the switch, and just remember that on Cisco boxes and in my experience, HP and Juniper and stuff like that, the odd numbered ports are on top and the even numbered ports are on the bottom. Okay, so 1, 3, 5, 7, and you got 2, 4, 6, etc. So basically that's how that would go. So the idea of the VLAN, when you have a bunch of switches that are, you have a switch that is out of the box, powered on, ready to go, every one of these ports are all going to be in VLAN 1. Now VLAN 1 is used for control plane. Okay, so CDP, your SNMP, all things that are going to happen between switches are going to be happening in VLAN 1. You can't disable VLAN 1. You can't delete VLAN 1. It's going to go across the trunk link whether you like it or not. So the idea here, and we'll take a look at that as we move forward here, the idea here is you likely don't want to use VLAN 1. And the reason for that is because of the fact that it is known by all people that know anything about networking that VLAN 1 is there by default. So if you have ports that are sitting inside of VLAN 1, so if you issue the show VLAN brief command and you see VLAN 1 and you see a bunch of ports listed, and then you see VLAN 2 and you don't see any ports listed here, that means that all the ports are in VLAN 1. We'll see what that looks like here in just a moment. So the idea here is when you're taking and you want to basically take this switch and you want to break it up so that maybe I'll just go ahead and add a bunch of ports here just so it makes more sense, so it looks like an actual switch, and we'll just we'll say this is the edge over here. What you're going to be doing is you're going to be taking these ports and placing them into different virtual local area networks. So we talked about in the previous video how a VLAN multiplexes a switch, how a VRF multiplexes a router, how a context multiplexes an ASA, how a VDC multiplexes a Nexus switch. Okay, so all of those different technologies all pretty much do the same thing at the end of the day. They allow you to take that device and be able to carve it up so you can allocate the resources that you need to the area you need them in. So in a case like this, if I have ports 1 through 5, I could come in here and type in, I want to create a VLAN first. So there's two ways you can do this. You can either do a VLAN 10 and go underneath here and give it a name. We'll say is HR. And then you would go interface range gig 0/1, gig 0/3, and gig 0/5, and then you would type in switch port access VLAN 10. Okay, that would put these 3 ports into VLAN 10. All right, so 10, 10, and 10, right? Now all these other ports that are don't have a number written inside them, they're still in VLAN 1. So what that means to you and I is these ports right here won't be able to talk to these ports over here. Now, is that a bad thing? No, but there is logical separation now between them. So when you're going forward, figuring out where you need to place VLANs and which ports you need to put them on is going to be very, very important. Now, a VLAN is going to be used in the data plane, right? It's a data plane. It's a way for you to break up the data plane ports. Now, there is a data VLAN, and then there's also a voice VLAN. Now, what's the difference between the two? Well, it's pretty obvious, right? This one carries regular data, this one carries voice. You can place two VLANs on the same interface only if you allocate it in a situation like this. To where, let's say, VLAN 10 is for HR, and let's say VLAN 20 is voice over IP. Okay, maybe you deployed Cisco UC or something like that. If that's the case, great. Now what you would do is you would go to that same interface range, and instead of typing in switch port access VLAN 10, you would type in switch port voice VLAN 20. And if you were to do a show VLAN brief, you would see VLAN 10, you would see gig 0/3, 1, 3, and 5. You'd also see under VLAN 20, you'd see gig 0/1, 3, and 5, respectively. And the reason why you see that is because you're allocating two different types of communication to that interface, and you go from there. So creating a VLAN is actually very, very simple. It's the actual, it's the inter-VLAN routing piece. We'll get to that once we get through BTP. We'll talk about layer 3 switching versus router on a stick and things like that. Very, very easy to work with. So what we're going to do in our topology here, we're going to bring this guy up, is I don't actually have a dedicated, didn't have a lab, but I'm just going to kind of bring one up on the fly. So what I'm going to do is I'm going to say that I'm going to split the network in half, basically. Just I'm going to cut this guy in two here. You know what? I bet you any money I've still got it as white, and I do. Alright, so I'm going to cut this guy in half. So router 1 is actually going to be, I'm going to put gig 0/1 and gig 0/2 respectively in two different VRFs. So what I'm going to do is I'm going to say VRF, I'm going to say net 10, and I'm going to say VRF net 20. So we'll have VLAN 10 and VLAN 20. This way here, I'll be able to go to these switches and I'll be able to create the VLANs and go from there. Now, we haven't talked about design yet, and we'll talk about that here as we go a little bit more forward once we start putting it together. Because I feel like if you understand, you know, where a VLAN fits into the mix, if you understand where, where trunking fits in the mix, and where you see VTP, then you'll be able to very quickly and be able to identify where you should be placing, you know, the design aspect of it. I think design needs to be brought in after you've understood the technology, because if we talk about the design before we talk about the technology, you may be thinking about a design and then you realize that the technology isn't supported in that particular design. So a lot of times the design is driven by the technology capabilities. And that's why it's really, really important to understand how, like for instance, how OSPF works differently than how EIGRP works with building out a design. Because if you go out there and you think that you're just going to be able to arbitrarily design OSPF to do whatever you want, and then you know you get a portion of the way through your proof of concept, and you find out that that's not actually the case, then you've got to basically backtrack and figure out where you went wrong. Where if you understood the technology better, and that's why we focus on the technology and not the certification. Even though we're teaching the technologies that are on the certification, I typically like to teach the tech and not the certification. This way here we can dig into, you know, knowing how VLANs work, how trunking works, how VTP works, and the different aspects of it, because then you can take it to the next level and say, okay, here we go. So what I'm going to do is I'm going to VRF out router 1. I'm going to show you guys how to do that. It's actually very, very simple. Because we're on the topic of VLANs. A VLAN is a way for you to logically break up a switch. You know, like I just said, you can place ports into VLANs and then they are logically separated from the other ports. A VRF, so this is layer 2. A VRF equals layer 3. When you're doing VRFs, you are doing the same thing as a VLAN. You're creating another routing table, and you're placing ports inside of that routing table. So you would go to the interface level and you'd say, you know, VRF forwarding net 10 or net 20, and that would allow you to logically separate the ports. So gig 01 and gig 02 won't be able to see each other anymore. They'll be in two different routing tables. So a VLAN is a way for you to subdivide up or multiplex a switch. A VRF does the same thing to a router. So if you understand the concept of VLANs, all you're doing is taking that same logic of a VLAN and you're mapping it to the layer 3 aspect. So let's go ahead and on switch 5 and switch 6, we're going to create two VLANs. We're going to create VLAN 10 and VLAN 20. And at the same point in time, we are going to go through and on router 1, we're going to create two VRFs. So I'm going to go ahead and pull up Secure CRT. And the way this will work out, you can just kind of go with the flow on how I'm going to go about doing this. So here's what we're going to do. I'm going to come in here and I'm going to say config T. I'm going to type in VLAN 10 and VLAN 20. Okay, so type in do show VLAN brief, and there's my exit out of here. There's my two VLANs. They're not named, but that's okay. So what I'm going to do now is I'm going to go to switch 6 and do the exact same thing. VLAN 10 and 20, exit, do show VLAN brief. So there they are. So there we have it. So now I haven't placed anything in, I haven't allocated a port to a VLAN. As you can see right now, there's nothing allocated right here for any of the VLAN information. So there's no ports there yet, but that's okay. I'm not quite there yet. I want to go in here and multiplex router 1. So I'm going to come in here and I'm going to bring up router 1. I'm going to go, host name is R1, and I'm going to type in do show IP interface brief. Now all my ports are shut down by default. What I'm going to do is I'm going to say that on interface, or I'm going to do this backwards and then do it the right way. So backwards means this. If I am, if you go to a switch, let's say switch 5, and I type in, I go to an interface, say I type in gig 0/2, and I type in that this is going to be switch port access VLAN 200. What it's going to do is that the VLAN doesn't already exist in the VLAN database. It's going to create the VLAN. So I type in do show VLAN brief. Now I have VLAN 200 and gig 0/2 is inside of that. And now it's squawking at me that there's a mismatch. So I'm going to say no switch port to access VLAN 200. And I'm going to say no VLAN 200. So there we go. So now it's deleted. So that's how you get rid of it. So now what I'm going to do is the same thing happens with a VRF. So if I go in here and I type in interface gig 0/1, I type in IP address of 10.1.10.100, or we'll just say 10/24. I type in no shut. And I go the same thing and I do this guy, but I type in 20.20 and do show IP interface brief, but I type in no shut. What you're going to see here is once that interface comes up, I have two interfaces in two different VLANs. Now the key factor here that needs to be understood is that these are two different VLANs, but router 1 won't be able to ping router 1 because they'll be able to ping each other because they're directly connected to the same box. Now, what I'm going to do here is I'm going to place interface gig0/1. I'm actually going to create the VRF. I'm going to say VRF definition. Now, or actually, sorry, VRF definition. I'm going to say net 10, right? What I'm going to do here is I'm going to say the route distinguisher, which makes the route unique. It's not to get into the meat and potatoes of VRFs, but it is the route distinguisher is placed in front of the IP address. So think of it like this, where if I was typing, 10:10, the IP address would show up behind it, 10.1.10.10. That's what it would look like if you were doing like MPL's L3 VPN. This is what it would look like inside of BGP. So that's basically where that comes into play. It's a way for you to logically separate traffic from, say, customer A from customer B. I'm going to type in address family, IPv4 unicast. I'm going to type in the route target is both, and I'm going to type 10:10. Okay. And then I'm going to go in here. I'm going to type in interface gig0/1, and I'm going to say VRF forwarding is net 10. Now it says that the IP address was removed because due to enabling VRF 10 or net 10. Now what ended up happening was I moved gig0/1 from the global routing table into the VRF net 10. By doing that, it removes the IP address because you're going from one routing table to a different routing table. So I'd have to type in the IP address again if I type in this and do a do show IP route VRF net 10, I don't have any interfaces in here. If I type in do show IP interface brief, you'll see that the interface is there's no IP address assigned. So I'm going to type an IP address of 10.1.10.10/24. Okay, and if I do show IP interface brief, there's the interface. If I do this again, now I have the interface inside there. A interface won't go into a routing table unless there's an there is no IP address assigned to the interface. Even if the interface is up, which you saw, the interface was up, but in the routing table, it's not there. It has to have an IP address assigned to it in order for it to be installed in the routing table. And there, we have that there. So now what I'm going to do now is I'm going to go into interface gig0/2, do show run interface gig0/2, and I'm going to say no IP address. Okay, I have the IP address there, but one thing you'll have to do here, we type in, we're going to exit out of here and type in VRF definition net 20. I'm going to type in the route distinguisher of 20:20 and address family IPv4 unicast, and type in the route target of both for 20:20, and I'm going to type in interface gig0/2 and type in VRF forwarding is net 20. IP address, actually I can go up here and copy this in like this. This is the right way to do it. If you have the luxury of doing this, if you have the ability to do this, I would go in and I would configure the VRF first, I'll place it on the interface, and then place the IP address on the interface at that point. So we type in do show IP interface brief. They're both IP address. We type in do show IP route. This is the local default routing table. Nothing's there. But if I type in VRF net 10, I have something there. If I do net 20, I have something in there. So they're in different VRFs. So that'll allow me to utilize the same box to answer for two different networks. So there we have it. So now we've created our VLANs, we've created our VRF. So from here on out, it'll just be a matter of taking that information and moving it to the next level. in regards to going to all the other switches and moving forward with the information, like getting the trunking in place, then getting the VTP to work, things like that. We'll talk about VLAN replication and stuff like that in an upcoming video. So that is pretty much how it breaks down. So that is basically how it's functionally that simple. So creating the VLAN is actually one of the easiest things you can do. So what I'm going to do now is we're going to talk about the parts to the VLAN information. I think that definitely needs to be understood. So I'm going to come in here on switch 5, and I'm going to come out. I'm going to do a show spanning tree for VLAN 1 or VLAN 10 or oh, I don't have an interface in that VLAN yet. So let's go ahead and place an interface in that VLAN. We're going to type in interface gig 1/1 and type in switch port access VLAN 10. Okay. Now we type in do show VLAN brief. We now place gig 1/1 inside that VLAN. And so we're in good shape at this point. We do the same thing on switch 6. We type in do show spanning tree for VLAN 10. Now there's something in there. And we'll talk about how this all breaks out here in a moment. We're going to go over, and there's a whole lot to talk about with spanning tree, but we'll take a look at that here in a moment. So we're going to type in gig 1/1, so interface gig 1/1, switch port access VLAN 20. Well, actually, sorry, I did that wrong. It's supposed to be the other way around. So on switch 5 is actually supposed to be 20, and this one's supposed to be 10. There we go. So do show VLAN brief. There we go. So now we're in good shape. So the key thing that I want to talk about now is if you do a show VLAN right here, this right here, notice how it's 4 digits long. The reason why it's 4 digits long is because it's a 12-bit number. So your VLAN numbers, if you were to do a VLAN question mark, a VLAN, notice how it says ISL VLAN IDs are 1 through 4094? Well, that's how many VLANs you can apply. That's numerical values, I should say, that can be applied to a VLAN number. So if I'm going to go in here and I'm going to basically set this up, I want to make sure that I understand where this comes into play. So this is 20. If I was to type in 3, it would show up in the 3. So there is a 12-bit number, and that comes into play with the VLAN ID. Now, you get 12 bits for VLAN assignment numbers. So that will come into play when we talk about spanning tree, which I believe is right up here. That will come into play with the system ID extension, and that will come into play when we start talking about how you can manipulate that type of stuff. But for the most part, the VLAN ID is 12 bits long, and you'll understand this more when we start talking about header lengths and things like that, because the .1q tag is 4 bytes. You're going to have the VLAN ID is 12 bits, so it's basically a byte in a nibble, if you will. Now, the drawback to this, and you might hear about this inside of the data center with some of the things like they call NSX or VXLAN, where you actually add a VXLAN header, which gives you, I think, 16 million options, which goes to 24 bits. So it gives you a lot more flexibility in that regard, which is actually one of the design limitations to VLANs. You only can have 4,000 of them. Are there networks out there with more than 4,000 subnets? Yeah, there are. How many subnets can you apply to a network? A lot more than 4,000. So if you start segmenting your network out, you can have way more than 4,000 networks, especially if you start using different address blocks. So a VLAN is normally associated to a subnet, but at the same point in time, if you have interconnections between your routers, normally, unless you're dealing within a lab environment, you're not normally going to be associating an interface to a VLAN or a .1q trunk or something like that. You're going to be allocating that to a subnet, and you're going to be having all these different connections that you're going to be needing access to. And the network that I have taken over, I'm basically a network architect for a Fortune 500 company. And one of the things that we have in our environment is we have a very, very robust corporate network. We have a very, very, very robust store network. So our corporate network and our store network are two separate entities that can talk to each other, but through a very, very restrictive firewall rule policy. And I'm at the point now where trying to understand the logic is the most important thing to me. When I'm looking at the configuration, I can figure stuff out because I know what I'm looking at. But it's understanding the logic behind it. Now, VLANs are not, like I said, VLANs in a lab environment are pretty common because then you can simply take a couple of routers, .1Q trunk them to a switch, and you're good to go. And you can get connectivity between them. That's how I do a lot of my service provider stuff. I connect them to a switch, and away I go. In production, you're not going to be doing that unless that router is acting is vertifying traffic out, maybe, or you are utilizing a switch to multiplex something. That router could be acting as a layer 3 gateway for multiple VLANs. I mean, it really depends on what you're trying to do. But normally, you're going to have more than 4,000 subnets in your network. I mean, if you start breaking it down, you could easily have, several thousand. I mean, if you have if you have a bunch of /27s, I mean, if you were to start taking /27s or /26s or point-to-point links, I'm a big proponent of point-to-point /30s in networks. You can have tens of thousands of those. It really depends on how big your network is. So usually, what you're going to talk about when it comes to VLAN information is typically what you're going to be going, instead of utilizing what they call end-to-end VLANs. And what I mean by that basically is this. If I'm here on router 1 and I want to be able to talk to router 4 over here, I'm not going to utilize the layer 2 access capability that is this. Right? I'm not going to get to my connection to router 4 via layer 2. So I'm not going to have VLAN 10 over here, or I'm sorry, in this case here it would be VLAN 20. VLAN 20 and VLAN 20 up here. Or I would have it there. But I would normally flip that over, and I would have some sort of layer 3 segmentation. So I wouldn't want my network to be one big layer 2 network. It doesn't scale well. So what I would normally do is I would take that and I would say, okay, the first piece of this is going to be, maybe this is my layer 2 bound, or my layer up here is my layer 3/layer 2 boundary. Maybe this is my access layer here, and then this is my distribution layer here, and then from here up is all layer 3. So these are all, everything up through here is all routed, right? And then everything down here is all switched. So we have a bunch of trunk links here that are port channeled together and things like that. And then I come up here to router 2, and then I have some sort of internet connection. Maybe I have a point-to-point VLAN. And I'm actually going to, I'm going to set up to actually make this look legit. And once we get the layer 2 pieces in here working, I'm going to talk about Nexus with switching separately than I will for iOS, so you guys will be able to see the difference between the two of them. I'm looking at setting up a LAN to LAN VPN between the two, so that if router 1 and VLAN 20 needs to talk to router 4 in VLAN 30, he'll be able to do so. But I'll set that up and show you guys how that works. So we're not going to be just doing CCNP switch. We're going to be adding a bunch of other features that might be applicable to you. So the same example might be up here, where all this is layer 3 up here, which is possible. Nexus does have the ability of routing. And then this will be our layer 3/layer 2 domain. And then down here is all layer 2. Right? We have, whether you're using fabric path, or you're using VPC, or you're using just straight up trunking, I really don't care how you get the job done. It's understanding the design and the logic behind it, which is why I wanted to wait till we went through and just broke down up through inter-VLAN routing, and then we'll start talking about the design. So normally what I would do is, this would be VLAN 10, or sorry, in this case here it's on the left side. This would be VLAN 20. VLAN 20 would terminate, but we have no more reachability into the rest of the network. This would be the broadcast domain in here. This section in between here, This would be the broadcast domain for VLAN 20. Up here, this would be some other VLAN. Let's say maybe this is VLAN, or maybe this would be some other layer 3 segment. Maybe it's 10.1.10.0/30. Something like that. And then up here would be another layer 3 segment, and up here would be another layer 3 segment. This would be another layer 3 segment, and then this would be another one. So you want to layer 3 segment things as much as you can. This way here will give you that flexibility of scaling the network. So you would terminate your layer 2 broadcast at maybe the interface VLAN on the switch, which we'll talk about coming up later. The layer 3 portion could be up here, or it could be up here. We're going to take a look at having it at this location here, this being the router on the stick, if you will, and then we're going to have it down here in the distribution layer. So I'm going to keep the scalability here so you guys can understand the logic behind it. But you definitely don't ever want to have layer 2 going this way. Meaning layer 2 end-to-end is a bad idea. Because let's say you have some sort of topology change over here, that information is going to be seen over here. So that is why normally we would not do that. Now there are some issues. There are a couple of things like, let's say for instance that you need to bridge layer 2 over layer 3. Maybe you need to use OTV, or maybe you need to utilize L2TPv3. Maybe you have virtual machines sitting over here in your data center that you need to make highly available over here. Well, in order for virtual machines to be able to do any type of interconnection, you need to have a vMotion capability between them. Well, vMotion needs to have layer 2 segmentation in the same VLAN, which means that this VM here and this VM over here would need to be in the same layer 3 broadcast domain. So that means they need to be in the same VLAN. OTV would give you the flexibility of basically being able to bridge that over a layer 2 or layer 3 data center interconnect. Now the data center interconnect can be anything. It could be an MPLS L2 VPN. It could be the internet. It could just be a layer 2 tunnel or a layer 3. As long as you have reachability from this guy here to this guy here, and he can reach this VM over here, then you're in pretty good shape. Now there are a couple other caveats that we won't get into, like shared storage and things like that. It's the network aspect of it that you need to be understanding. But that is one of the key big factors here. So we don't want to have a situation where we're going in here and we're running layer 2 end-to-end. And I've actually moved several companies away from that design because it doesn't scale. You wouldn't want your New York office of being affected by the LA office because somebody rebooted a switch because it was being buggy. You wouldn't want to have that type of convergence. And then bridging the VLANs over the WAN, that's just wasted resources. Especially a while back, say the early 2000s when we were still on frame relay and ATM. Even though ATM could forward faster than frame relay, but the concept was the same. You're still trying to bridge layer 2 traffic over a WAN. Was never a good idea. That's why layer 3 segmentation is such a big deal. So we'll take a look at this in more detail. If you guys have questions about this, feel free to ask. But as we progress through here, this will pretty much be how I break it out, and as we go along, so you'll be able to put all the pieces together. So if you're not sure where we're going with it right now, don't worry, we're going to get there in time. But that is basically how it works. Now, once you've created a VLAN, and I don't want to get off too far off the beaten path here. Once you create a VLAN in one location, whether it's this switch here and this switch here or elsewhere, that's really all you really need to be able to do. Create the VLAN. That's all you're going to do. You can name it if you'd like. Enter the VLAN ID number and then type in the name, and then go from there. Now, on top of that, once we get a little further along, we start talking about trunking, we'll be able to get the connection between all these other switches up and running, and then we'll be able to move into the next step, which is going to be replicating VLAN information. Because unlike, and I didn't want to get into this until I was in trunking, but this might help tie some things together. When you're looking at a large domain like this, you need to make sure that all the switches in that layer 2, that have layer 2 access to that particular VLAN can see that VLAN. So that's why I'm a big proponent of bringing the layer 3 edge as close to the access layer as I can. The reason for that is because if I do something where it's one big layer 2 topology, so let's assume that I'm layer 2 from here all the way down to here, right? This is my layer 2 domain. That means if I have, let's say for instance, this switch 6 over here is a 6513 and it's got 10 by 48 port line cards at gigabit speed at 1 gig. That means I have 480 ports here, 480 ports, and I have 480 ports over here. That's 960 ports between the two. Now double that and you have what? Assuming that these are access layer switches, so you're going to have both PCs and you're going to have phones. So you're going to have double the MAC addresses. And so you're going to have that capability. So you're going to have, that's going to be like 2,000 MAC addresses between these two switches. Well, guess what? Every switch here is going to have to know each one of those MAC addresses. It's going to have to know how to get from here. If I have a device over here that wants to talk to a device over here, the MAC address information has got to be known. Now let's assume that we take this a step further. Let's just say that this is a 6513 and it's got the exact same port density. You've got access layer switches in a couple of different places. Well, normally you wouldn't do that in distribution layer, but just kind of go with the flow. So that's another 480. Multiply that by 2 because you got this over here. Multiply that by 2 because you've got phones. So you got 2,000 here, and you got 2,000 here. That means that this switch also has to have, for every additional switch, you're doubling the MAC address load. Because if this guy's kicking out 2,000, this guy's kicking out 2,000, this guy's kicking out 2,000, this guy's kicking out 2,000. So I've got 2, 4, 6, 8, 10, 12,000 MAC addresses that I have to know how to reach in my network. That's a massive amount of layer 2. And it just doesn't make sense. Why would you want to do that? And then, let's take this to the next step. Let's say that you went over the layer 2 over the WAN. Let's say your VLANs are end-to-end and you're not doing what they call local VLAN. Now I'll talk about that here in just a second. Local VLANs are a little bit different. So if I'm doing end-to-end VLANs with following the red line, that means that I'm going to have to learn MAC addresses from here. Or going to have to know about MAC addresses from here. It doesn't scale well. That's why it's not a good design. Where local VLANs come into play is you're mapping the VLANs per location. Now you can have the same VLAN numbers in multiple locations, so that 4,000 number isn't really a limiting factor anymore. It's the subnet specifics. So that's why you would give subnet blocks out. That's where layer 3 segmentation comes into play. So you would simply come in here and you would say, okay, this is VLAN 20, this is VLAN 10, this is VLAN 20, this is VLAN 10. It works in both locations. They're just different layer 3 subnets. So this could be 10.1.20.20 or 20.0/24. This could be 10.1.10.0/24. Okay, this one over here could be 10.2.20.0/24. This could be 10.1. or 10.2.10./24. Because all you're doing is you're changing an octet in the subnet mask or in the subnet, and you're in a completely different broadcast domain. So layer 3 segmentation is absolutely huge, and it's pretty much a critical factor when we're getting into this. So we'll take a look at this as we're moving forward, but it's really, really important to understand this and how it would work. So pretty much how it breaks down. So what I'm going to do is we're going to stop there. I think I've covered the logic and the theory so you guys will understand that. What we're going to do next is I'm going to do it on the Nexus so you guys can see how that gets put together. And we're going to do the exact same thing over here, but we're going to give router 4 a different broadcast domain. So we're going to set it up that way. So until next time, guys, thanks for watching. You guys have been great. If you have any comments, questions, concerns, or you'd like to see something that I haven't covered, or something like that, leave a comment below. Thanks for watching.